Good day, students. Welcome to part 5 of the Algebra 2 Trig Regents exam for January 2013. On this installment, we're going to be going over questions 26 through 30. All right, let's take a look at question number 26. It says if log 2 is equal to a and log 3 is equal to b, the expression log 9 over 20 is equivalent to which of these? So let's go ahead and do some quick review on logarithms, properties of logarithms. The product property of logarithms basically tells us that log a plus log b, the sum of logarithms, is the same thing as the product of the arguments of the log a times b. Okay? And then log a minus log b, this is the quotient property, is simply log of the quotient of the arguments a over b. Okay, so whenever you're adding logarithms, it's the same thing as multiplying the arguments of the logarithm, and whenever you're subtracting logarithms, it's the same thing as taking the quotient of the argument of the logarithms. Okay, if you notice, these logarithmic expressions do not have bases in them, so that basically tells you that is log base 10. So log of 10 is simply going to be 1, because we know that without a specific base, the default base is 10. Okay, now since we have log 2 and 3 and also log 10, the task is as follows. We know log 2 is a, log 3 is b equals b, and then log 10 equals 1. So the goal is to express 9 and 20 using a combination of 2, 3, and 10. And then if we can do that, we'll make a substitution of the corresponding logarithmic values, and then we can express it using one of these answers here. All right? So log of 9 over 10 over 20, sorry, we can basically break this down using a factor trees into its prime factors. So log of 9 is 3 times 3. All right, I made use of 2 3's because I know what 3 is. And then 20, I can write it as 2 times 10. Okay, because I know what log 2 is, a, and I know what log 10 is, which is 1. All right, so now what I'm going to do is I'm going to substitute these values of those logarithmic expressions in here, and then we can re-express them. Okay, but before I make a substitution, how about we apply the properties of logarithms here to, actually I have to apply the properties first before I make a substitution. All right, so let's go ahead and apply the properties. Now you notice there's a times here, so I'm going to have log of 3 plus, remember whenever you're multiplying the arguments, you add the logs of each argument, of log 3 plus log 3 divided by, so division, remember division is a minus. Okay, now we have to be extremely careful here. 2 and 10 are in the denominator, so when we want to transform them into this expression, we have to put the parentheses grouping them together. Okay, so this is going to be log of 2 plus log of 10. Alright, this is a big mistake most people make. They forget to put this parenthesis and they express this as a minus and a plus, and then you definitely fall into a trap. Alright, so now we can make our substitutions. Log of 3 is b as indicated here, so this is b, plus log of 3 is also b, minus parenthesis log of 2 is a, and log of 10 is 1. Alright, let's simplify this. We have 2b. Now this is why I say you have to be careful, because this minus is distributed to the a and the 1. It changes both signs, not just one. So it's going to be minus a minus 1. Alright? If we forgot to put the parentheses, we'll select option number 1, which is wrong. The correct answer is option number 2. So please, please, please be careful with your signs, okay? Alright, now let's move on to question 27. So 27, there are two ways of doing it. There's a ridiculously long way, and then there's a shortcut. I'm going to show you the shortcut because we don't have time to waste. Okay. All right. So if you think back to your difference of squares formula, how do you factor a difference of squares? If you have a squared minus b squared, it factors into a plus b times a minus b. Yes. So that's exactly what we're going to do here. We're going to say let a be x plus I. All right. And then let b be x minus I. All right. So a squared minus b squared, a squared minus b squared. Let me change my colors here. So let's see, let a be in green. So a squared minus b squared is going to be what? As we indicated here, it's going to be a plus b times a minus b, right? So we're going to have one quantity where it's going to be a plus b, and then the second quantity is going to be a minus b. Okay, so a plus b, and then the next quantity is going to be a minus b, all right? A minus b. All right, so why am I using all these colors and writing it like this? You're going to see in a minute. So in this problem, a is x plus I squared. So we're going to have x plus I squared minus, and then b squared is going to be x minus I squared because we know that b is x minus I. Okay, so if I apply this formula, a plus b, a minus b, the difference of squares formula, I'm going to have the quantity x plus I plus, what is b? b is x minus I, right? So I don't need the parentheses here because I have a plus, plus x minus I. All right, so this is a plus b. And a minus b is going to be a, which is x plus I, x plus I. Now, since we're dealing with a negative, we have to use a parenthesis, right? b is going to be x minus I, x minus, close enough, wrong color. X minus I, let's write that down, x minus I, all right? So there you have it. All right, so what we'll just do now is just simplify and that'll give us our answer, okay? So over here, x plus x is 2x. The i's are opposites, so they basically add up to 0. They cancel each other out. So for the first quantity, I have 2x. And then for the second quantity, I need to make the distribution here. I'm going to write it as x plus I minus x plus I. Okay? If you notice, the x's are opposites, yes? So that means that they cancel out. They add up to 0. These ones cancel out. And then you're going to have, it yields 2x times I plus I is what? 2i, right? And then when you multiply 2x and 2i, your final answer is 4ix. So our answer is option number 4. Okay, now let's move on to the next question. In question 28, we're asked to determine the first 20 terms of the sequence whose first 5 terms is 5, 14, 23, 32, and 41. So we're given the first 5 terms, we have to find the sum. If you refer to your reference sheet, the sum formula of a sequence, in this case, this sequence, is it geometric or arithmetic? We have to be careful here. If it's arithmetic, that means we have to keep adding the same number over and over again. So to go from 5 to 14, assuming it's arithmetic, we have to add 9, right? So if I add 9 to 14, do I get 23? Absolutely. So since we keep adding repeatedly, it's geometric. So we have to make sure we use the right formula. So the formula for the sum of n terms of an arithmetic sequence is n over 2 times a1 plus an. So what we need to generate our sum is n, a1, and an. Okay? So n is the number of terms you're adding up, which is 20. That's good. A1 is the first term of the arithmetic sequence, which is 5. That's good. And then we need an in this case. An is A20, the 20th term. What on earth is the 20th term? We do not know because we are given only 5 terms. So there are 2 ways we can do this. We can keep adding over and over again until we get to the 20th term, which takes too much time. Or we can use the nth term formula. All right, so let's go ahead and make use of the nth term formula for a geometric sequence. So I meant to say arithmetic sequence. So for the nth term, we're gonna take a detour, okay, to find a20. So let's take a detour real quick. To find so let's write our goal. We want to find a20. All right, because without a20, we cannot use this formula. All right, so the formula for the nth term of an arithmetic sequence is given by a1 plus n minus 1d. All right. If you forget this formula, then you have to just figure it out. Keep adding 9 over and over again until you get to the 20th term, okay? So 820 equals the first term, which is 5, plus the number of terms, which is 20 minus 1 times the common difference. The common difference is D is given by the formula A2 minus A1. If you subtract the term from the previous term, then you get the common difference, okay? So a2 minus a1 is basically 14 minus 5, which is 9. Well, basically, what number do you keep adding over and over again? That's your common difference. In this case, you keep adding 9 over and over again. So and d is 9, all right? So times 9. All right, so 820 equals 5 plus 20 minus 1 is 19. 19 times 9. And then when you compute this, you would get 176 as your 20th term. All right? Now, we now know what 820 is, so we can now compute the sum of the first 20 terms. So 820 equals 176. So now 8s sub 20, sum of the first 20 terms is n, which is 20 over 2. I'm not plugging everything into this formula since I have everything I need, okay? Times 5 plus 176. Simplify that, 20 over 2 is 10, 176 plus 5 is 181, 181 times 10 is 1,810. All right, so there goes your final answer. All right, well, let's take a look at question 29. It says determine the sum and product of the roots of this equation. So to do that, let's first of all find what the roots are, okay? 3x squared equals 11x minus 6. Uh, to find the roots, we have to first of all put this in standard form. So we need to subtract 11x and add 6 to both sides so we have it equal to 0. Because the standard form of a quadratic equation is always equal to 0, right? It's ax squared plus bx plus c equals 0. All right? So we have to put in that formulation first. So we have 3x squared minus 11x plus 6 equals 0. Now let's try factorization here to determine the roots. If that fails, we can always resort to the quadratic formula, which always works, okay? So I like to use the x cube to factor. I have a 3-part tutorial on factoring quadratic trinomials on matlabserve.com. So if you don't know how to factor, go over those tutorials and you'll be a master in no time, okay? All right, so AC goes on the top and B goes on the bottom. AC is 18, B is negative 11. How do we know? This is A, this is B, and this is C. All right. So what two numbers multiply to give you 18 and add to give you negative 11? Negative 9 and negative 2 fits this description. So let's put that in the center. We have 3x squared minus 9x minus 2x plus 6 equals 0. All right, let's break it down the center. We're going to factor by grouping right here. Break it behind the middle right there. All right, so from the first two, I can factor out 3x. I factor out 3x, and I'm left with x minus 3. And then from the next one, I can factor out negative 2, and I'm going to be left with x minus 3 also. All right? Now, these two quantities that are identical, I can factor them out as x minus 3. And I'm going to be left with 3x and negative 2. Put them together in their own parentheses. There goes the factored form. Okay, now we're going to apply the zero product property to solve this completely. So we're going to have x minus 3 equals 0, or 3x minus 2 equals 0. To solve this for x, you just add 3 to both sides, and we have x equals 3 as the first first root. And then for the second root, it's two-step. Add 2. We have 3x equals 2. And then we're going to divide by 3. Let me go partition my workspace. So let's go up here. 3x equals 2. Divide by 3. You have x equals to 3. All right. Now we ask for the sum and the difference, right? So let's start by looking for the sum of the two roots. The sum is going to be the first root, which is 3, plus the second root, which is 2/3. Okay, let's express this as 3 over 1. Find the LCD, multiply by 3 top and bottom, times 3 times 3. So this is going to become 9 over 3 plus 2 over 3, which is 11 over 3. Okay? And then we also asked to find the sum and the product. This is the first answer, that's the sum. The product is simply 3 times 2 over 3. How do you multiply these? Well, express this first number as a fraction. So you have a fraction be multiplied with a fraction. So you multiply across, top times top, bottom times bottom, 6 over 3. 6 divided by 3 is 2. So there goes the answer. So our sum is negative 11 over 3. And I mean, it's 11 over 3, and our product is 2. All right, so there goes our answer. So sum 11 over 3, product 2. Okay, now let's move on to question number 30. Question 30 says if secant A plus 15 is equal to cosecant 2A, find the smallest positive value of A in degrees. So I'm going to solve this one using a calculator, but we know that the standard TI does not have a secant and cosecant function explicitly built into it. So what we're going to do is we're going to express it using their reciprocal trig identities. All right, so for this one, secant, we want to solve secant A plus 15 equals cosecant 2A. All right. So what I'm going to do here, we can express secant is 1 over cosine. So we can write this as 1 over cosine A plus 15. And then secant 2A can be written as 1 over sine 2A. How do I know this? How can I make this substitution? Well, we're using the reciprocal identities, right? Remember that secant theta is 1 over cosine theta, and you also know that cosecant theta is 1 over sine theta. Okay, these are your basic reciprocal identities. That's what I did here. So you can cross multiply these two expressions. So we're going to have sine 2a is equal to cosine a plus 15. All right, so what I'll do is I'll just graph these two and then compute the first intersection, and that will be the answer that satisfies this description right here. So let's go ahead and do it. So let's see. Okay, so I'm using degrees here, so let's make sure we have the right mode. So because my calculator's mode keeps changing, there you go again. So make sure I'm in the degree mode. All right, so I have it there. Go to y, enter the first function, sine 2. I'm going to use x because that was a standard independent variable for the graphing function. So instead of a, I'm going to put x, okay? And then for the second function, I'm going to graph cosine x plus 15, like that. Enter, bam, graph. All right, so there you go. See, there goes the graph. It makes no sense, looks terrible. But if we zoom it into the trig world or using trigonometric calibration, then the graph will look much better. Look like something we can use. Okay, so we're gonna zoom 7. Okay, anytime you graph in trig functions, always zoom using a trig window. Okay, zoom 7. That's more like it. That makes more sense. Something we can work with. All right, so there goes the two functions. The first one with the smaller period is sine 2a, and then the one with the bigger period is cosine um, a plus 15. All right, so let's go ahead and find the first intersection. So if you take a look at this window, this intersection right here, that's our first intersection of the two graphs, okay? So let's see, what we're going to do is calculate the intersection. All right, so let's see, trace. Let me just show you something. See, this is the first function, sine 2x. And then when I jump alpha up arrow, I jump to the next one. This is cosine x plus 15, okay? So you see this intersection right here. It's kind of like 20 something, I don't know. Anyway, this intersection right here is the answer, all right? So let's go ahead and find that intersection. So we're going to use the calculation menu in the window. So second function, trace, should take us to the calculate menu. Scroll down to item number 5, enter. It's going to ask you for two curves, okay? Because we're computing intersection of just two curves, or actually the calculator does intersection of two curves at a time. All right, so first curve, enter. Second curve, enter. Guess means that put the cursor at the area, the point that is closest to the intersection. You know there are multiple intersections here. So what I'm going to do is move this cursor to a point around the intersection. It doesn't have to be exactly there, but the calculator can guess what you're talking about. Okay? All right, so press enter. Boom. X equals 25. So this is the smallest one. There are bigger values for x that satisfies this expectation, but this is the smallest one. That's the one they asked us to find. So for our answer, A is basically, based on the graphical result we have, A is equal to 25 degrees. Alright, so you see how a graphing calculator can be used to solve a systems of equation problem. So there you have it. But thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking here for updates on new next installments of this review series. And please post a comment to let me know what you think about this presentation. More clips can be found on math.serve.com. Thanks again and have a wonderful day.